Now I'd like to introduce you to some aromatic compounds in which there are more than one ring that are fused together. And the simplest scenario is when I have two benzene rings that are fused together. So notice, I have a total of 2, 4, 6, 8, 10, so 10 pi electrons. It satisfies Huckel's rule, and when n equals 2, it's cyclic, still cyclic, it's planar, it's fully conjugated, and therefore it's aromatic. This particular structure is called naphthalene, right? And you find naphthalene in mothballs. So, uh, maybe if you've been to your grandparents' house in their attic and they're storing some clothes with mothballs, you have been in contact with naphthalene. Now, I can also have three fused rings. And in this particular structure, again, you see you have a total of 2, 4, 6, 8, 10, 12, 14 pi electrons. So n equals 3. So it satisfies Huckel's rule. It happens to be, obviously it's cyclic. It is planar. And it's fully conjugated. This particular structure is called anthracene. And if we think about, three fused rings, we can actually fuse three rings in one of two ways. This is one of them. Another way is like this, right? So it's not kind of a linear fuse ring, but it's a bent. This particular structure is called phenanthrene. And there are lots of phenanthrene derivatives found in nature. It happens that phenanthrene is a little bit more stable than anthracene. If you take a look at anthracene and you think about a Kekule ring, in anthracene, the ring on the left is what we call a Kekule ring, right, where you have alternating double single bond. The ring in the middle is also a Kekule ring. You see an alternating double single bond. The ring on the right is not a Kekule ring, right? Because there's a double, single, and then a single bond, and that's really the best way that you can draw it. With phenanthrene, you see that all three rings are Kekule rings, and because of that, it is actually a little bit more stable than anthracene, and it's also found in nature much more than anthracene is. We can also look at hetero polycyclic aromatic compounds. So here I've taken pyrrole and fused with benzene, and this is also an aromatic compound, which the benzene ring has 6 electrons, and then the pyrrole ring is contributing 4, so that's a total of 10 electrons, right? Remember the lone pair of electrons on the nitrogen is part of the aromatic system. And this is called indole. We can do the same thing with furan fused to benzene. Again, benzene is giving the 6 pi electrons. The furan is giving 2 from the double bond, 2 from one of the pair of electrons. And this is called benzofuran. And similarly, you can do this with thiophene as well. And this structure is called benzothiophene. Now, the interesting thing about indole, benzofuran, and benzothiophene is these are extensively found in nature.